not the fall, but it's the sudden stop that gets you. Well, that's the saying at least. But is it true? Yes, it's very much true. But why is it true? What does this tell us about jumping on trampolines, surviving great falls, and even just getting stuff that's stuck on your shoe off? Well, anyways, remember, you can understand this. You got this. Okay, let's get into it. Howdy everyone, I'm Biscuit. And to understand stopping after a fall, we first need to use Newton's second law, which I talked about in some detail in my previous video. But to recap, Newton's second law says the sum of all the forces on an object equals its mass times its acceleration. Recall that acceleration is the change in velocity over the change in time. So in our case, we can actually do a bit of an approximation. We can approximate this as the difference between 2 points, just like a slope in Algebra 1. Now, when hitting a ground, an object goes from having a high velocity to zero velocity. So let's choose these 2 points as just hitting the ground and then after this object is stopped. On the other side of the equation, we have both the force of the ground pushing back up and the force of gravity. But note that the force of gravity is just a number and isn't going to vary in this discussion. So instead, let's focus on the other force of the ground pushing back up. So no matter what, we need to go from some velocity down to zero. But depending how we get stopped, this could take a longer or a shorter amount of time. The longer time it takes, the lower the force the ground will exert on us, and therefore the safer this slowdown will be. This is why falling on a trampoline is much safer than just falling on concrete. The time to fully stop is much longer, and therefore the force experienced over this will be much smaller. You can see how parachutes are an extremely exaggerated version of this. And although the math will end up being a bit different, we can see how taking a very long time to fall will result in a much smaller force over that time. We tend to naturally move in ways that take this into account intuitively. Like when we land, we bend our legs or fall over or do a roll. Anything to slow down over a larger period of time. This also explains some of the incredible stories of people surviving from great falls, where they've hit trees or tree branches or awnings, and while that may all be painful, these have helped slow down the person and minimize the large, potentially fatal force when hitting the ground. This large force is the thing that breaks bones and damages organs, as there's so much trauma and force our body is able to take. Conversely, we sometimes use this to our advantage the other way, where if we stop something really fast, we can create a large force. For instance, when trying to shake snow or sand off your shoes, you usually slam them on the ground, typically on concrete or wood. So the time to stop is rather short, causing the force to be large, and that large force results in the stuff to fall off your shoes more easily. So if you find yourself falling, try to extend the time it takes to slow down, as a smaller force applied over a longer period of time will slow you down safer than a large force, all at once. Okay, thanks so much for watching. Really appreciate all the support lately. Stay safe, everyone. Okay, thanks, bye.
Notice that when he walks, he's bending his knees. Hi Cody. I get to show off my kittens now. Hi Cody.